So my part consists to do actual correlation mining by using R. So here our objective, in our study is to be able to monitor and perform an early prediction of patient depression severity, and we think that's really helpful in essential for the agency to improve the health quality and to give better treatment to those that suffer depression. That's really difficult and harmful mental health, and our main objective is to be able to predict the depression. So with the goal of addressing this prediction problem, several patient samples were collected and were given by the agency. For each patient sample, different parameters were measured, as well as the economic status and the discrimination rate. Some other characteristics of the patient information collection process were stored, such as the employment, which is nominal. It's a nominal attribute. So we also have the substance abuse index and so on. The main objective of this study is to provide a better understanding of the factors influencing the patient depression, leading to the patient depression. Namely, we want to understand how these frequencies or how these depression are related to certain attributes, parameters, as you can see here, related to, for example, substance abuse index or the discrimination and other characteristics. As such, obtaining rules or models that are able to accurately predict the patient depression based on factors, on properties that would facilitate the creation of cheap and automated systems for monitoring depression and specify the severity of this depression. So here, as you can see, we use this training data, this data set with 677 samples. So in order to treat them, to analyze this data set, we use R via RStudio. RStudio is really great, powerful, user-friendly tool to do data mining. So here, as you can see, we already loaded the data set into R by using this command. So here we call the function read.csv. So it takes as the first argument and the data set, which is this file. So here we have another parameter is true, and this indicates that the file to be read does include a first line with the variables names, which is true in our case, and so that's why we did mention this. We did enable this parameter, and we also have the argument take, and this argument states that the numbers use that point character to separate decimal places, and the last parameter that we specified is na.strings. Here it just gives to the variable whose values are how can I say, unknown or known to be interpreted as a certain value. So here we just want to replace these unknown values by the value NA. This is a pretty common notation for unknown values, in data mining. So here, as you can see, enter, and if we want to have like an idea of the statistical properties of the data set, we can just enter summary. Summary will give us that. And so to actual correlation data mining, we're gonna call the function core. It will produce a matrix or table, if you want, with the correlation values between the variables. So here we want for all the variables included in the data set. So that's what we use, and we also want to tell or to disregard observations with NA values in this calculation. We only want the real data. So that's why we use this parameter pairwise that complete that obs. So here, as you can see, it's a table. So we have the different variables in the rows and columns. So here, as you can see, here we can see that substance use index is highly correlated with the discrimination rate, and that's something really helpful. And here we also see that it's also correlated to depression. So in our data, even if the correlation are in most cases irrelevant, however, there are three exceptions between these two variables: substance use index, discrimination, and depression. So that's why we're gonna work with these variables in order to predict the depression based on these two factors, discrimination and substance use index. So to have a clear idea, to have an accurate number, we can use the function core. So here, what we want to do first is just to give us the correlation number between depressed, the variable depressed, and discrimination. So as you can see, they are kind of correlated. So we also want between, for example, depressed and substance abuse. As you can see, they are really highly correlated. So that means our hypothesis is correct. So we can accept our hypothesis to work with highly correlated factor, with the depression, and we can also see the highly correlation between substance abuse index and discrimination. As you can see here, we have it here. So, and this cream, so yes, so -0, that's 8.4. So here, yes, this is just another example, another proof that these three variables are really related, correlated, and this is what we have to use. So my partner is going to use another tool called IBM SPSS to do the same thing, to do the correlation and linear regression. So from there we will try to find a rule to predict the depression, to better understand how uh, they can lead to the depression, which variables lead to depression. Here we can see it's substance abuse indicator and discrimination. So we want to go further and find a rule that will verify, this correlation, that will support this correlation.